All right, IM3 classes. Today we're going over Pythagorean Theorem. Hopefully this is something you have seen before and kind of remember. If not, that's okay. That's why we are going over it again. But we use Pythagorean Theorem to find missing side lengths of right triangles. This works for right triangles only. So the definition of the Pythagorean Theorem is in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. That's a really wordy definition. We're going to simplify that here, make that a little bit easier. But what's important to remember about Pythagorean theorem, and actually, it only works for right triangles. If it's not a right triangle, you can't use this to solve right angles. And then the story behind Pythagorean theorem is actually pretty fascinating. We won't get into it in this video, but if you're in class, I'll talk about in class about Pythagoras, the name, the guy that the theorem is named after, and how he maybe didn't even exist. So fascinating story about that. But anyway, when you have a right triangle, some things you need to remember about right triangles is they have a little box in the corner to denote the right angle. So a right triangle has to have a right angle, and there's usually a little box in there to show that it is in fact right angle. So this means a right angle. And the reminder, a right angle is 90 degrees, right? The different parts of a right triangle are the two legs and the hypotenuse. The hypotenuse is the longest side of a right triangle. And then the two legs are different sides. So if you look at textbooks and stuff, they'll call it the long leg, short leg, or short leg, long leg, and hypotenuse. I find that some kids get confused when I call it like the long leg. They think I'm talking about the hypotenuse because the hypotenuse is the longest side. So what I do is I call it the short leg, the medium leg, and then the hypotenuse is the longest side. But anyway, what are you going to do to find the hypotenuse? First thing you should do is label the sides A, B, and C. We're going to use Pythagorean theorem is A squared plus B squared is equal to C squared. Label the sides A, B, and C. So the longest side is always C. Right, the hypotenuse is always C. That's the one side you need to take care of first. Label that one first, and then the A and B are interchangeable. It doesn't matter which side you call A and B, as long as you label the longest side C. So A is 8, B is 6, C is what we're trying to find. And that got messy. X. So we are squaring it. So 8 squared plus 6 squared is equal to x squared. And then from here, what we're going to do is just solve the equation for x. You need a square first. So 8 squared is 64. 6 squared is 36. Is equal to x squared is just x squared. 64 plus 36 is 100. Is equal to x squared. And then you square root both sides. Square root of 100 is 10, is equal to x. So quick reminder, so when we were dealing with square roots, remember we used to, when we said square root of 100, well, for square roots you need to include a plus or minus because it could be a positive or negative 100. When we're dealing with triangles, we're dealing with actual distance here. Distance can't be negative. The length of this side can't be negative 10. That makes no sense at all. So we don't have to worry about putting a plus or minus 10. It's just 10. It has to, distance has to be positive. So the distance of that side is 10. No plus or minus necessary for Pythagorean theorem problems or distance problems. So another example, again, find 8 or label the sides A, B, and C. So C is the longest side. And we have A and B are the other two sides. Again, we're going to use Pythagorean theorem. A squared plus B squared is equal to C squared. So A is 5, B is 12, square those, and C is X. And then just solve that equation. So 5 squared is 25, 12 squared is 144, x squared is x squared, 25 plus 144 is 169, is equal to x squared. And then final step, square root both sides, solve for x. Square root of 169 is 13. All right. We can use Pythagorean theorem to also find sides that are not the hypotenuse. So again, we're going to label the sides. If you're not sure which side is the hypotenuse, because if you look at these two sides, I mean, at a glance, it might be difficult to determine which one is the longest side. Take a look across from the right angle. That's always going to be the longest side, the hypotenuse. The hypotenuse always, always, always across from the longest from the right angle. So longest side is C, then A and B, doesn't matter what you label the other sides. To find that missing side, we still use Pythagorean theorem. So A squared plus B squared is equal to C squared. A is X, B we labeled as 9, and C is 41. We need a calculator for that one. I don't know what 41 squared is on the top of my head. Anyway, X squared is just X squared. 9 squared is 81. 41 squared. Let me get a calculator here. Uh, 41 squared is 1,681. Next, what we're going to do is solve for x squared. So we need the x squared by itself. So I'm going to subtract 81 from both sides here. So I get x squared is equal to 1,600. Now I can square root both sides. And then x squared is x, square root of 1,600 is 40. So the missing side length is 40. Right. Sure. We'll do one more of those. Again, label the sides A, B, and C. The longest side is C is always across from the right angles. That's C, A, and B. Use Pythagorean theorem. A squared plus B squared is equal to C squared. A is X, B is 16, C is 20. All right, so we get x squared plus 16x, 16 squared is 256. And then 20 squared is 400. Solve for x, I'm going to subtract 256 from both sides. I get x squared is equal to 256, or 4 minus 256 is 144. Square both sides, square root both sides, excuse me. I get x is equal to 12. So the side is 12. Cool. So that's Pythagorean theorem, but deal with Pythagorean theorem is it's not always going to work out to whole numbers. Those are actually pretty special cases that it works out to a whole number. Most likely it's going to work out to something that's not a perfect square when you come down to it. And so what I want you guys to do, if your answer comes out to something that's not a perfect square, just put it into simplified radical form. That means just use the buddy system to simplify any square roots at the end. So here, let's do this. Label sides A, B, and C. C is always across from the right angle. It's the longest side. So here's A and B. We're going to use Pythagorean theorem. A squared plus B squared is equal to C squared. A is 12. B is 1, getting ahead of myself, 13 squared. And then solve for, actually, x, C was x. I'm going to solve for x. 13 squared is 144. Or excuse me, 12 squared is 144. 13 squared is 169. Equal to x squared. 144 plus 169 is 313. Square root both sides. Square root of 313. That is not a perfect square, so we need to do a buddy system on it. So I'm going to do a factor tree over here. 313. What are numbers that divide 313? We'll start with 3. No. So I'm just doing this on a calculator. So 313 divided by 7. No, that doesn't work. 313 divided by 313 divided by, let's try 13. No, at this point, I'm just going to go ahead and do this. This does not, there's no buddies or anything that's going to come out here, nothing. That does not simplify at all. So we just leave it as the square root of 313. There's no partners. That one's a tricky one. All right. Let's look at another example. So here, we are going to use Pythagorean theorem to solve for x. So we need to start off labeling sides A, B, and C. And this one's important because even I was just about to go ahead and label x, C. But remember, the longest side is always across from a right angle. 20 is the C on this one. 8 is, we can do A and B. It doesn't really matter. So I labeled A 8. B is x. C is 20. Don't forget the squares. And then I need to solve for x. So 8 squared is 64. Plus x squared is equal to 20 squared is 400. Subtract 64 from both sides. So plus 64 minus 64, that cancels out. I get x squared is equal to 336. So this one, that is an even number. So 336, I can divide that by 2. Let me use a calculator to help me out. So 336 is 2 times 168. 168 is 2 times 84. 84 is 2 times 42. 42 is 2 times 21. And then 21 is 3 times 7. So when I square root both these sides, it's going to be x is equal to, I got to do buddy system on the 336. So I have 1, 2, 3, 4 2s and 1, 3, 1, 7. So 2 times 2 times 2 times 2 times 3 times 7. Look for pairs. Pair of 2s, 1 on the outside. Pair of 2s, 1 on the outside. No more pairs, so I get x is equal to 4 root 21. There we go. One more example I want to show you. This one can be a little tricky because there is a radical as one of the side lengths. We're just going to do this the same way. A squared plus B squared is equal to C squared. Label the sides A, B, and C. Remember, your C is always the longest side of the triangle. The hypotenuse is C. The A and B then don't matter, are the other two sides. So A is X plus B is the square root of 257 squared is equal to 18 squared. So I have to solve this here. We'll do this easy one first. 18 squared is 324. And then here, square root of 257 squared, the square root and the squared, that just cancel each other out. So we just have 257. Now I can subtract 257 from both sides. Get 67. So x squared is equal to 67. Square root both sides. There are no buddies in 67. So it's just going to be the square root of 67. And we are done. That'll do it for this lesson. Next time we're going to talk about special right triangles. Fun times. See you then.